Okay. Good morning, everyone. Let's get started. Today we are going to develop our first discrete event simulation. Um, this is the operations that we are going to model. We are considering an urgent care operations, which has multiple exam rooms. This picture it has two, but we can play with the number of exam rooms. Patients arrive at different points of time. If the examiner are busy, they wait in the waiting room, and as soon as a patient is done, the next person in line goes and see the physician, and then they leave the urgent care. So one point to emphasize here is that discrete event simulation is a general purpose modeling framework. So we use this example as an illustration, but you can use discrete event simulation for essentially any other systems that you like to model. For example, if for your project you think Markov models are not appropriate for the disease that you have chosen, or you are not satisfied with the assumption of Markov model, you can still use discrete event simulation for modeling disease progression. Okay, and to study the impact of different alternatives or interventions. So the urgent care that we like to model, we are going to take 4 input variables or input parameters or inputs. These are our model inputs. The number of exam rooms, we like to give our model how many exam rooms to include, the hours when the urgent care is open. So if a patient comes after the urgent care is closed, we do not admit the patient. 3 is the patient inter-arrival time. So that means that the time we have to wait until the arrival of the next patient. So for today, we are going to assume that this inter-arrival time is fixed at 0.25, 1/4 of hour, and this is a mistake here. It should be 2.5 instead of 1.5. So we are going to assume that this is deterministic and this is fixed. And duration of exam, we also need to provide that. We're going to assume that each exam takes 0.5 hours. Okay, we are going to make these probabilistic for maybe in the next lecture. But for now, we are going to assume that these are fixed and deterministic. Now, some basics about VBA. As you may have noticed, VBA is an object-oriented programming language, which means that to develop programs and application, we create these objects that interact with each other. So that's why VBA is an ideal for modeling, because this is exactly what we want to do in our urgent care. Okay, we want to create these objects, these patients, physicians, nurses, and that's one of the main reasons we use VBA, because it's the object-oriented programming language. So what is an object? So objects are things that have characteristics. We refer to these as properties. They have functionality, methods, and they are able to react to events. Here is an example. So we have been working in Excel, so you are pretty much familiar with worksheets. Okay, worksheet has some characteristics or property. It has a name. You can give it a size, title, etc. It also has some functionality, so it does something for you. You can save a worksheet, you can open a worksheet, you can calculate. Remember F9 or Control F9. This recalculate the sheet, and it also reacts to some event. So if I right-click on a worksheet, I will see a pop-up menu. Okay, these are the events that we have associated to this object, the object worksheet. All right. And so we talk about object. Now, another important concept to know is class. So objects are instances of a class. A class defines all object properties, methods, and events, and if you find it confusing, you are not the only one. Essentially, classes are recipes for making burgers, all right? Object is the burger itself, okay? Just remember that. So classes are recipes to create things, and the objects are the things themselves. So now you can use a recipe. We refer to it as class in the programming world to make as many burgers or objects as you want, right? Now, in a technical terminology, when you make a burger, essentially you instantiate a burger from the class or the recipe, all right? So we make a burger by following the burger recipe. It is equivalent to make an object by instantiating a class, all right? So just remember that classes are recipes, all right? And objects are instances of those recipes. Okay, if you follow the recipes, you make something, and that's the object. Now, if you are, a little bit more interested in the technical differences between object and classes, the main difference is that the class is only a description of how to make an object. So it doesn't consume any memory. But when you instantiate a class to create an object, then the object will reside in the memory of your computer. Okay? So we talk more about this, but those are some important distinctions. But the take-home message is that classes are recipes, objects are the product, the food. So in our model, in our urgent care model, we are going to create objects or classes for patients. We have a waiting room, we have exam rooms, and the urgent care itself that includes all these recipes, all these objects. All right, so that's where we are heading. So for the lab today, you don't have to, I mean, you are more than welcome to follow what I'm doing, but you don't need to be worried about falling behind. Okay, so it's up to you, and I'm also recording the screen, so if you want to look at what we are doing today later, I will also post the video online. But make sure to ask questions, all right? So stop me whenever there's something unclear. It's a good opportunity to clarify everything before moving to next subject. So if you want to follow what I'm doing, or if you want to do it yourself, you can open the Excel file urgent care model, number 1 basics, and make sure to submit this file just to get the participation credit. Okay, even if you're not doing the lab with me, just submit the file to get the credit for today's lab. So these are the settings of our simulation. We like to specify the number of replication. We usually specify the time to stop the simulation. So this is 10 hours. I'm going to run it for 100 hours, for example. You can play with it. So these are the inputs of the model. The urgent care hours, I'm going to assume that the practice is open for 18 hours. I'm going to start with the 2 exam rooms. Again, we play with this. Patient arrival times 0.25 and exam duration 0.4. Okay, so these are the inputs of our model. So in our model, as soon as the urgent care has to close, we of course serve the patients who are in the urgent care, and then we don't admit, or at that time we don't admit any new patient, but we finish the service to the patients who are in the urgent care. The reason that we have this parameter time to stop simulation is to make sure that if, because of any reasons, the condition, the termination condition is not satisfied, we have some other condition to stop the simulation. Otherwise, it would go for infinite amount of time. Imagine that there are a lot of patient comings, then we might not be able to serve all of them. So we have this additional condition to at some point we stop the simulation, right? So we this thing would, we make them clear as we are moving forward. So these are the important thing. So these are the inputs of my model. Now, if I open the VBA, so the first step is to have a module. I can add a module here. I'm going to name it, and to rename it, I can do it in the properties window. So if you don't see the properties window, go under view, and this is property windows. You get that here. All right.
Or on Mac, you just click on the module.
Oh, thank you. Yeah. So I'm going to rename it to urgent care simulation. Right. Now, every simulation model that we implement in VBA needs to have a main sub so that I can run the model. So that's the sub that I'm going to call to run the model. So I'm going to implement that here. So public sub main, and I'm going to leave it empty for now. Okay. I use term public because I want to call it from Excel itself. Okay. So this is when I want to run the model, this is the sub that I'm going to run. Now, if I go back to the Excel, I want to add a button that I can click to run the model. So I can go under developer in PC, then I can add a button. Okay, so I add it here, and then this assign macro windows would pop up, and my main sub is listed here. So I can just select that and then click OK. I can also rename this simulate. All right. So now if I click on it, it doesn't do anything, but because the sub is empty. All right. This is when I click on it, it runs this sub. Right. And again, feel free to stop me if you have any questions. Right. So the next step is to create our patient class. Okay. To do that, we can do insert, then class module. Okay. We are, again, you remember, we want to create the recipes for making patients in our model. So that's why we use class. So let's add a class module. We can rename it to patient.
On Mac, you just right click on modules and go to insert, the option insert class module.
Thank you. All right, so now we have a recipe for creating patients. It is empty, but we can use it. So if you want to use this recipe to create a patient, you can go back to under main. We can use name, my maybe favorite patient as patient. See, this is VBA intelligence in action. So it gives you the name patient here. So VBA knows that we have some recipe for creating patient. So this patient is here. All right, so this is our recipe. This is how I create a patient. So this is how you can define a patient in VBA. Okay, this is the recipe or class, which is here, under classes. And this is an object that I just created according to patient recipe. The important thing here is that we need to use the keyword new. Okay, this is how we tell VBA that we have a and a specific recipe for our patient. These are objects, okay? And this is how we tell VBA to go find the recipe for patient and create my favorite patient for me, okay? Right? Now, we can go back to our patient recipe. There are, of course, when the patients come into our urgent care, we need to be able to differentiate them from each other. Okay, so in practice, what we use is maybe their social security number or the name, address, and this kind of information. Here, we can go with something easier. Okay, we can just define an ID for each patient. So every time a patient comes into the practice, I give the patient an ID. Okay, I can start from 1 and increment it anytime a patient comes. All right. So now we are essentially defining a property for the patient class. So I'm going to use private ID as you can use integer. So this is essentially a number that I'm going to assign to each patient. Okay. Now I use integer here, but one thing you need to remember is that if you click on integer and then if you hit F1, you can see the ranges where an integer variable can change over. So let's see if we can get it. Okay, so you see here the integer, if I have an integer variable, it can change from minus 32,000 to plus 32,000. So if I'm modeling a bigger operation, which during a day I might serve more than, for example, 32,000 patients, then I may run out of IDs. All right. So a better way is to, instead of integer, define this variable as long. Okay. Now, if you look at the help again, you see that a long variable has a much wider range. Okay, it is from, you see here, it goes up to, I don't know, 2 billion almost. Right. And again, if you fall behind, don't worry about it. You can watch the video if you want to do it yourself, or you can follow the notes. So the important thing is, make sure that you are understanding what we are doing here. If you have questions, let me know. We can spend more time on each of these concepts. All right. So this is how we define a variable to store the one property of this patient. I'm going to add this underscore at the end of these local variables. So if you have noticed, I use the term private. So private here means that this variable that I just defined is only accessible by what I'm going to implement in the class patient. Now, if I want to access to this variable, I need to make this variable public so that I can ask, when a patient comes, I can give them an ID, and then later on, I can ask for the ID. Right now, what I have done is as if the patient knows their ID, but is not willing to share with me their ID. Okay, this is private. Now, to make it public, we define a property. So we define a public property. We use the term get to get the ID. I'm going to name it ID, and the type of this property is long. Right? The same. It must have the same type as this private ID. So now if I want to return it, I set the name of this property to my local variable. This is my local variable, which is here, and this is how I return it. Yes.
private have to do with where it's saved? Private data.
So it has to do with accessibility. So we will, when we gradually build it, you see that, for example, I create this patient, I have an exam room. So exam room cannot access this private variable. So the exam room cannot ask the patient for their private ID unless I add this property to make it public. Okay, this is kind of a mechanism for VBA to make sure that you want to reveal information that you intend to. Okay, so we make many of these properties private, just for the patient. And if I need to get some information, I'm going to use property to make it public. Okay, we will. We will see more examples shortly. So now I have a patient. The patient has some variable ID, and this is how I get the ID of a patient. So now if you go back to our main sub, I can, this is how I can ask my favorite patient about their ID. So if I type the object name, if I hit dot, then VBA shows me the public properties of this patient. Okay? So this is, I can, this is how I read the ID of this patient. All right? So now we know how to create a patient and read the patient's ID, but we haven't yet implemented anything to give the patient their ID actually, right? So there are two approaches. One is this is a read-only property. I can change it to be able also write on ID underscore. So to do that, I can use again public property, and this time I need to use let. Okay, I'm going to use the same name, and we will talk about this keyword later by val, but for now, let's keep it there. Okay, and okay, this is how we implement the additional properties so that you can write on patient's private ID. So you see, you see the main differences. First of all, this is our read-only property, so that's why we use get. Now, if you want to be able to assign an ID to a patient, we use the keyword let. Okay? And this is the value that we are going to assign. And this line essentially assigns the value that I just passed to the private patient ID. Right? So now if I go back, you can see that, again, you can do the same thing. My favorite patient ID. Now I can assign, for example, 1 or 1, 2, 3 to this patient. Right? So now ID of the patient, I can assign an ID to the private variable ID underscore, and I can also read it. So a better approach is to have a formal instantiation sub. So you can, this is to make it public sub create. Okay. So what's happening here is that when I create my patient, then we can have a formal instantiation sub that we can always run and pass all the information that we need a patient to have to be created. Okay, again, we see more example, but here I can use, again, my favorite patient dot create, and then I can pass the ID here. Now, you might have many more properties for the patient that you want to initialize the moment that the patient is created. So you may want to give the patient some priority. Okay, you can do that here. I mean, assuming that you implement the additional argument. Or the patient might have some other, like the patient comes with a special clinical needs. You can add that here. So instead of defining different properties, different public properties, we can initialize all the information that the patient needs in under the sub create. And again, bear with me, this thing would become more obvious as we move forward. So I'm going to delete this one because I have already implemented a sub to take the patient ID, right? So now what happened here is that this is how I create my object, my favorite patient. I'm telling VBA that there is a recipe for it. Go find the recipe. The keyword new is important. This is how we tell the VBA that this is actually an object. After I created the object, I use this formal sub to give the patient its ID. All right. And if along the way I need to read, the patient ID, I can just use my favorite patient and dot ID, and that gives me the ID of that patient.
Can you explain how does it know that if you're not saying ID, that 123 is creating its ID? Like, can you spell that?
Yeah. So.
And why you deleted the my favorite patient.id?
So say that again. The next part.
Like you deleted the my favorite patient.id for 123, because I guess that was like extraneous information. But can you just explain why that was extraneous and how it knows that by just doing .create that it's talking about ID?
Because the first argument of this sub is ID, and that's how it's assigned. So if I go back here, when you when you open the parentheses, you see that it prompts you that this is the ID that you're passing.
Is there a way to create that on Mac to prompt?
Oh, it doesn't prompt Mac?
It doesn't come up. Like we don't get drop downs like that.
No, I don't know, but
okay, but I get it. So,
yes,
okay.
yes. But Will had a very good idea about installing some software. Is that right? Will, maybe you can share that with the class so that if they want to have access to Microsoft Excel, they can.
Yeah, so I think as we mentioned before, Excel, VBA on Mac is somewhat computer. And so I think if you want sort of experience the full version, I'd either recommend using one of the PCs in the Stat Lab, or a somewhat more tedious but free option that might help you going forward is to install a virtual machine, run Windows on your Mac. They give you for free through Yale by first installing an open source virtual machine emulator called VirtualBox from Oracle, and then you install Windows and Office for free through Yale.
Yeah, maybe that's something to consider if you. That makes things easier because this prompt helped you a lot. But anyway, so I created the patient, and I'm going to pass the ID for this patient. So that's how we create a patient. This is the recipe, and this is the object. All right. Next, we are going to create the waiting room. All right. Okay, so again, similar to the patient class, you can add a new class module. We are going to rename it as waiting room. All right. So again, now I have the recipe for creating waiting room. It is empty, but if I go back to my main sub, I can do my waiting room as new. Again, you see that the waiting room is shown in this pop-up menu. Okay, so now it tells know that there is a recipe for creating a waiting room. Right. So let's go back to the waiting room class. Now, what we need, again, similar to reality, is that these patients come to the waiting room. We need to put them in order. Okay, we need to have an explicit way in VBA to contain them, right? And the way to do that in VBA is by using collection. So let's create a collection. So I'm going to make it private. It's going to be patients as collection. The collection is a built-in class for VBA that you can essentially store any object. So this is how collection works. It has some index 1, 2, 3, and you can add any object into this collection. Okay, and now we learn how to work with it, but that's the idea. That's what we exactly need for our waiting room. So this is a collection of my patient. I'm going to also implement a sub to instantiate this waiting room. So I'm going to make it public sub create. Now, if you remember, whenever we want to create an object, we need to use the keyword new so that Excel allocate the appropriate memory for it. So that's what I'm going to do under here. So I'm going to use new collection. All right. So let's see what's happening here. So at the top of this class, I have told VBA that I'm going to have the variable patients underscore, and the type of this variable is collection. All right. So essentially, I have told VBA that you know where to find the recipe for creating this line, this queue of patients. What I'm doing here is that now I'm specifically telling VBA that go and follow the recipe to create my line, my waiting room for me. Okay, this is, and the keyword set is also important. This is how we assign an object to an object. All right, so remember, before, if for example I had a variable of type integer, in order to assign a value to it, I would just do, find a variable and then I assign 1 to this integer. Okay, that's how we initialize variables. But with objects, the keyword set is important. This is, we make it explicit. That we are assigning objects. All right. So again, at the top of the class, I'm declaring patients. The type is collection. So I'm telling VBA that, okay, remember that I have a recipe for collection. This is a built-in class for VBA. So I don't need to implement anything for collection. VBA knows how to deal with these collections. Then when I create a waiting room, I'm explicitly telling VBA that now go follow the recipe and allocate some memory for me to keep track of my patients in the waiting room. right? Now again, we see examples, so you can bear with me. So here I have defined my waiting room. Now I'm creating a waiting room. Now remember that sometimes you get an error when you are calling a sub, and that's why that I don't know why sometimes it's okay to eliminate, to drop the keyword call, otherwise sometimes not, but it's good practice to always have this keyword call whenever we are calling a sub. So if you remember, create is a sub. In order to call a sub, we use a keyword call at the beginning of the expression. Okay. Now, one trick to check if you have done a good job for now is to, if you go under debug and then if you click on compile VBA project, it checks roughly the syntax of your code, and if there is any problem, it gives you some error messages. Okay, so far so good. So if I go under debug and then click on compile, there's no error message showing, so it's good. All right, so I have created the class for patients and waiting rooms. Now, yes. Sure.
So the call, what is it referring to when it's calling?
So call is whenever you want to run a sub, it's good to, just make it a habit of adding this keyboard at the beginning of the, so create both, yeah, at the beginning of each sub. If you have a sub, we have sub here, and there's another sub here. So whenever we want to call them, we use the keyword call. Now, another trick, if you want to, see where does it take you if you execute this line, you can right-click on the name of the sub, at least in PC, and then you can click on definition. Okay, then it takes you to the sub. But do we have that in Mac or no? Okay. So, same as here. So if you have a create definition, it takes you to the sub for this page. All right. Now I need to be able to add patients to my waiting room. Right. The way to do it is I will implement a public sub. I'm going to name it add a patient. All right. So what I want to do is to pass a patient to the object waiting room, and this object will put the patient in collection. Oh, I'm doing it on the wrong class. So let's go to the waiting room. Right. So I want to pass a patient and put the patient in the collection. Right. So let's use again. We come back to by val, what it means, but for now, whenever we pass something, we use the term by val at the beginning. This patient, and we need to specify the type of this variable, which is patient. Okay, enter. So add this patient to the collection. The way to do it is patient is the name of my collection, and it's a dot. It shows you the add method, and just type this patient here. Okay, so very intuitive, isn't it? So you pass a patient, you add the patient to the collection. Now I know where the patient is.
Why are you using patients underscore versus collection?
So I don't know why VBA shows this line here, but there's a underscore here.
Right. Why are we're using the private, we're adding the private patient to the public,
So,
to the waiting room?
so the collection that I've defined is private. So only the waiting room sees the collection of patients. All right. Now, this patient will be sent by the urgent care object that I'm going to implement later. All right. So the urgent care send the patient to the waiting room. So this patient comes from my urgent care object later on, and then I add this to this private collection, which is fine. You know that no one can see. Again, based on the way that I'm implementing it. Okay, I want to keep as many variables as possible private. Okay, because that's make things easier. All right, I only want to when I so if you remember, here you if I click here, I can see only properties and functions that are public. So although they might a lot more things happening in the patient, but I don't need to make it visible. That's the main reason to make things public. And also you can prevent unintended errors by making sure that you only make things that matter public. Okay, so that's essentially what's happening here. All right, so this is I added a patient. I also need to be able to retrieve the next patient in line. Okay, so whenever exam room becomes empty, I'm going to my waiting room and retrieve the next patient. All right, does it make sense? So the way to do it is to write a function, okay, because I'm returning something. So let's make it a public function. I'm going to call it next patient. And since it is a function and it returns something, I need to specify the type of the object that is returning. So the type is patient. Okay, I'm going to get the next patient. The next patient. So I use the keyword set because I'm assigning a patient to the name of this function. So I set, and I'm looking at the collection, which is patients underscore. You can use the method item and the first one. Okay. This is how we retrieve the next patient in line. Yes.
Methods are pre-built into
the collection. Yes, the collection is pre-built. So the collection has some pre-built properties. So if you patient, so see it has add. If you want to add something to your collection, it has count. It gives you how many members are in your collection. It has item if you want to retrieve an item from a collection, and remove if you want to delete. Yes.
The collection has pre-built methods.
Yes. 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 Exactly. So next, I have to remove this patient from the waiting room. So remove the patient. That's how I use remove one. Remember that remember these indexes. So one is the patient in front of the line. Now, if I remove this, VBA will automatically reorganize my waiting room. Okay, so now the second next patient comes to the first position, and so on. So this is get the next patient. This is essentially add a new patient. All right. So I have, this is my recipe for a waiting room. It has the collection of patients who are waiting in the waiting room, and I know how to add a new patient to this collection and how to get the next patient who is waiting in the waiting. All right.
So is the value for this patient, does that change every time?
Yes. So now let's go back to urgent care. So here I have my favorite patient. I gave it 1, 2, 3 ID. I built my waiting room. Now I can put my favorite patient in the waiting room. Dot, add a new patient. And remember that remember to use the keyword call. And this is how I add a patient to my waiting room, right? Now this time I'm using my favorite patient. Next time I'm gonna use my second favorite patient. Right. So, all right. Now if I want to get the next patient in line, I have to define a new variable or new patient. So let's call it next in line as patient, and then next in line is my waiting room dot next patient. All right, this is how we get the next patient. Yes.
So is my favorite patient one particular patient?
Exactly. So
and why do you have this like one particular patient as opposed to just like patients like 1, 2, 3, 4?
so this is just for illustration, but we correct it. Okay, we will create as many patients as we want. Okay, but this is just for practice. So I have a favorite. I put it in the waiting room. All right. Now, if I want to retrieve the patient, we need to make sure to define a new patient. This is again, we tell VBA that next in line is a patient, and we need to put set because we are assigning an object. So next in line, I look at my waiting room and I call next patient. All right, that gives me the next patient in line, and I put it in the next in line variable. All right. And now let's go back to the waiting room class. I also want to know how many people are currently waiting in the waiting room. So I can define a public property. It is get, and the type is, you can give it long. So public get. Oh, use it. Okay. So I want to know how many patients are waiting in the waiting room. Okay. So this is the name of the property. I need to assign a value to it. So this is again patients. This is my collection, and I use the count method of the property. That gives me how many patients are already in the collection or in the waiting room. Okay. So now if you want to see what's happening, we can step into our program. In PC, it is F8. What is in Mac? Well, do you know? To step into, oh, there is a button for it, is there? All right. So let's Anyway. So for PC, you can right click here and then you can see the debug menu. If you right click on the menu, you see that some of the debugging functionalities. So but the easier way is to just hit F9, if F8. So if I do that, this yellow line shows me what is being implemented. So if you just notice, the VBA jumped over the first line because, again, as I mentioned, we are not doing anything essentially here except that we are telling VBA that, okay, there's a recipe, but don't do anything. There's a recipe. So if let's do it again. So if I hit F8, we have on the main menu, on the main line, if I hit F8 again, it jumps over the first line because that is, there's a recipe, and then I'm going to create this patient. So my favorite patient now, if I hit F8 again, it goes on to the patient class. If you hover your mouse over ID, you see that this is the number being passed, and this, the local ID is 0. The ID that I pass is 1, 2, 3. After executing this line, now the local ID is 1, 2, 3. All right. So now I created my patient. Next, I create the waiting room. So this is I allocated patient. Now I'm going to add my favorite patient to the waiting room. Right. So now if you want to see exactly what happens, you can double click on patient underscore, and if you right click, you can add a watch here. So this shows me this is my collection, and there is nothing in it. Okay, this is my patients collection. Nothing is here. If I execute this line, I get an error because I didn't add call here. Okay, let's do it again. Make sure to have, if you're following my steps, make sure to have call here. All right, so let me go back to the, all right, I'm creating a patient, I assign the ID, I'm creating the waiting room, I initialize the collection in the waiting room. See, if you hover your mouse over the patient, it shows nothing after this line. Now you have a collection of patients. It is empty, but you have it. So next, I'm going to add this patient to this collection. So this here shows my collection. Nothing is there. After here, you see that we have item 1. Item 1 is my patient who has ID 123. Right? Now, if I want to retrieve this patient, this is how I'm going to do here. This is the next patient in line. I'm retrieving the patient. You can look at my collection. So in my collection, I have item 1. This is my patient with ID 123. This line, the line that I just executed, assign that patient to the next patient, and this line that has removed will remove that patient from the waiting room. All right, so the patient is gone now. The patient is assigned to next patient. So I hit next, and next in line, if you check this patient, this is 123, the next patient in line. All right, so you can play with it at home if you want. Is there any questions before we go? Yes.
So like the different rows and the watches, those are different patients?
No, these are expressions that I added to keep track of what's happening to them. So let me delete these. So I can do it again. For example, if you can keep track of what's happening to your favorite patient. You can drag and drop it. So now we have this expression here. It shows the value. So after I create this patient, you see that my favorite patient now has some value. So this is a way to see what's happening to these objects. Okay. So I created this patient. I created the waiting room. I'm going to add this my favorite patient to the collection in the waiting room. Again, if you want to see what's happening to it, add a watch. After this, you have your favorite patient in the waiting room. Right? So let's close it for now. Okay. So we have implemented the waiting room, the patient. Next, we are going to add exam rooms. My recipe to create an exam room. So I'm going to rename it to exam room. Again, I need to be able to distinguish exam rooms from each other. It's like having a room number. So I'm going to have ID for my exam rooms. And I want it to be public so that I can see, I can get the ID of each exam room, property get ID. Remember that it needs to, we need to specify the type of this property. All right. Now, similar to patient, I'm going to have this public sub. I'm going to name it create, and I will pass an ID. All right, so nothing new. This is same as before. Okay. So I create an exam. This is like a room number. I give it a room number or ID or whatever. Now, an important property of exam room is whether it is busy or not, or the status of the exam. Okay, so that if an exam room is busy, I cannot send a patient to that exam. Okay, and if it is idle, I can. Now, we can, one option is to create a property, call it if busy, and we need to define a Boolean that takes only false or true. Okay, but a better way is to use VBA enum method. So what it does, okay, let's add it here. So I'm going to have a public enum exam room options. Okay. So what I did here is that I defined a variable, but this variable can only take two values, either or busy. Okay. The advantage of this approach is that if in the future I need to add additional status, I can easily do it. Like, in preparation, for example, I can say 3, and now I have 3 status. Okay, but I don't need this here. So again, enums are variables that take specific values. Okay, so if I define integer goes from 1 to 30,000. With enum, I have a specific value, and also it comes with some description. Okay, and I show you how it works now. So when I also need to define a private variable to store the status of this exam room. I'm going to define it as exam room status options. Okay, So instead of now I have a new type of variable. So remember, before we had long, these are built-in VBA variables. Now I have exam room status options, which are defined here. Okay. Now when I create an exam room, I'm going to assume that it is idle. Okay, so the way to do it is to set to the status, and again VBA IntelliSense gives me these options, busy and idle. These are the options that they have defined here. Okay, I'm going to assume that initially the exam room is idle. Whenever I create an exam room, it's empty. Okay. Is there any questions? Now I want to also be able to check the status of an exam room. It is as if, I go knock the door, see if there's anyone in the exam room. So I do it by adding this property get status, and the type of status is the same type of this local variable, which is exam room status options. Status, I'm just going to set the number to the local variable status. Right. So another thing I need to keep track of for each exam room is the patient who is being served. Okay, so I'm going to define this variable patient being examined as the type is patient. Okay. Right. Right. So next step, we are going to define the events that may occur in our urgent care. So we had two events, the arrival of a new patient and the end of service. Okay. So let's add a new class. We name it simulation event. Right. So again, I'm going to use enum to specify the type of this event. Type. Okay. Now the properties that I want this class to have, I want to know the event type. I also need to know if I define an event, I need to know when it is going to occur. Okay, so I will also have event time, and it is going to be double. So again, if you hit F1, you get some information about the type double. So it varies from -1 point, this gives you the range. So if you are working with real numbers, we use double. If you work with integer numbers, we use long. All right. So I also okay. So if I define an event for the arrival of a new patient, I need to know which patient is arriving. Okay. So that's why I also going to have this local variable and call it patient ID, and my patient ID is of type long. This is only for arrival of a new patient event. For end of service, I also need to know which room the patient is departing from. So which room number, for example. So I'm going to keep that in this local variable. This is okay. How are we doing? So again, this is the recipe for creating events. We have two events in our urgent care model. You might have as many events as you like. So the two events that we have is arrival of new patient and the end of exam. I defined an event type. This is an enum. So I pre-specify the value that this variable can take. I need to know the type of the event, the time of the event, and if this is an arrival, I need to know which patient is arriving. And if it is an end of exam, I need to know which room I should go and retrieve the patient from. That's why I have the end exam ID room. Now let's make these public because we are going to use this in our simulation. So public property, first one, event type. Event time, public property, get event time, double. I can just copy this twice. Patient ID. This is long. This is long. Okay. Now we are going to have two different create subs for this class because we have two different events. Okay, so I'm going to implement one sub to create an arrival of a new patient event, and I'm going to have another sub for the end of service for a patient. Okay, create. So create. Okay, so if I want to create the arrival of a new patient, the things I need to know is the ID of a patient and also when this is going to happen. Okay, so these are the variables I'm going to pass. So I use byval and event time. No, yeah, event time text double. And remember, if you want to break a line, you add underscore and then you can come to the next line. Byval, this is patient ID as long. So I know that this sub is going to be called when I want to create the arrival of a new patient event. So therefore, the event type is, you type event type underscore equal, then it gives you the options that you have. So it's going to be the arrival of new patient. Okay. Then for the time of this event is event time underscore and record the patient ID. Okay. You don't have to, follow all the steps. Just make sure that you're understanding what's happening here, and you can look at the code later. I will make it available online. But more important thing is to understand what we are doing. Okay. Now this is the sub to create a new arrival. Now I need to implement a sub to create the end of exam event. So it's going to be relatively the same. So I'm just copy and paste it down. They make a mistake.
Yeah, event time equals event time.
Oh, thank you. Thank you. All right. So this is create end of exam event. So I'm going to create an end of exam. I need to pass the event time, and instead of patient ID, I'm going to pass exam room ID. So now type of event is end of exam. This is the same, and instead of and occasionally you can click on debug, compile, see if you're getting any error. So again, I'm implementing this recipe. If I want to create and the arrival of a new patient, this is a sub I'm going to call. I'm going to pass the time of this event and also the ID of a patient who is going to arrive. And I'm for the end of exam, I'm going to pass the time of the end of exam, and also the exam room ID, where I need to go retrieve the patient for whom we just finished service. Okay. Now, is there any questions? Now, if you remember, we discussed that the way that the algorithm for discrete event simulations work is that they keep a calendar of future events. Okay, so I schedule everything on my calendar and I advance time to the next immediate event. Now I have implemented the calendar class. Oh, I didn't put it on the website, so maybe I do it quickly on the website in case you want to import it. Here. Okay, you should be able to download this. And if you are not able to import it, if you click on it, you see the code, and yeah, you need to copy and paste it from option explicit. Okay, if you want to copy the code from option explicit, copy it. Otherwise, if you can import it, you can just download and import it into your VBA. So the way to do it is if you click on File, Import File, then look for the file simulation calendar. Okay, and then it adds it to your project.
So we can make a new class module.
Yes, if you are not able to import, add a new class module, and then copy and paste the text from under including option explicit. So copy from here down. Oh yeah, I should have said.
Like after you
Yeah.
Yeah.
Oh, there it is. Cool.
Do you all have option explicit when you add a new module, or no? If you don't, this is you can do it under Tools Options. If you go under Tools Options, I mean at least in PC, I don't know how to do it in Mac, so it's okay, just type it. But if you are in PC, then check Require Variable Declaration. This is again some VBA mechanism to make sure that you are using variables and objects that you have already declared. Okay, so it prevents errors. So it's good to have. If you don't have it, just type it whenever you add a new class or module. Okay, so let's go through the calendar quickly. So this is so I'm going to have a collection. I'm going to have a collection again for the event. So it works similarly to my waiting list. Okay, so this is VBA kind of collection. These are the location of members. So from one, I'm going to put the earliest event here and the latest event at the end of the collection. All right, so this is again like I'm creating a calendar. Now, if you go back to the code, the properties, I need to know the current time. So I need to be able to ask my calendar what the current time is. That's the local variable for that. I need to know the number of events that are scheduled on the calendar. So when there is no more event scheduled, that means that that's end of my simulation. Okay, nothing else is going to happen. That's where my simulation ends. This is the current time. This is if I want to ask for the current time. Now let's go through this sub together. This is for scheduling an event to my calendar. Right? This event, I'm passing this event, and the type of this variable is simulation event. This is either arrival of a new patient or the end of service. Okay, when I pass it to my calendar, first of all, I check if the calendar is empty. Okay, if the calendar is empty, then we can schedule this event. We can add by adding the event to the collection. Okay, so it goes right here on the first. If the calendar is empty, if nothing is scheduled on the calendar, when I add a new event, it takes the first location. All right. Now, if the calendar is not empty and the latest event scheduled on the calendar is going to occur sooner than the event that I want to schedule, then I'm going to schedule my new event at the end of the calendar. All right, does it make sense? Are you with me? So if the calendar, if there is some event scheduled in the calendar, I'm going to check what is the latest event in that calendar. Then I'm going to schedule my new event at the end of, after that, if the time of new event is later than that, right? So this is what we have here. So if the event that I just added is the time is greater than or equal to the event time of the last item on my calendar. This is how I get the last item. Remember, the events is a collection, count, give me the number of events in the calendar. So if I have n events in the calendar, this is where my last event is. So if that's the case, then I add the event to the end of the calendar. So when you do add this event, it schedule it at the end of the calendar. Now, otherwise, I need to go through the event and find the correct location of this event. So here is an example. So this is, for example, my first event. It is going to occur at time 1.2, second event 1.8, maybe 2.3, and so on. Okay. Now I have a new event that I know is going to occur at time 2, right? So now I need to go and find the location of this new event. All right, this is how calendars work. All right, again, intuitive. So if this event is 1.2, 1.8, this is 2.3, if my next event is going to occur, or the event that I want to add to the calendar occur at 2.0, this event should be scheduled before event 3, right? That is what I'm doing here. So I go through the events in the calendar, and when the time of event I is greater than the time of my current event, the event that I want to add, then I add that event before I. This is what we did here. All right, so I'm going to check the time of these events. I reach 3. 3 is 2.3. This is greater than the time of my event that I'm going to schedule. So I add it before 3. That's the keyword before. That's for that purpose. All right, and this way I keep my calendar in a chronological order. So these are the earliest event, these are the latest event. Okay, so 1.2, maybe the last one is maybe 10.2. You want to add a new event, the time of the event is 2. We search the calendar, we start from here, and as soon as the event that is already scheduled in the calendar, the time is greater than the time of new event, then we schedule behind it, right? Is there any question? How are we feeling? But the good thing is you don't need to memorize anything. It's already coded, but you need to know what's happening. This is again, like if you want to, when you have a to-do list, okay, you can sort it by the deadline. That's what we are doing. These are the time of these events. We are going to sort them so that I know which event is going to happen next and which event to happen to next after that. All right, so this is our events. This is our calendar. All right, so this is how we get the next event. Right, when to get the next event, again similar to the waiting list, I'm going to set the event that is located in the first location. I'm going to return that. Whenever I ask for the next event, I'm going to update the current time of my simulation, and I will remove the event from the calendar. Okay, similar to the waiting room. And I also have this sub if I want to clear the calendar. So what I'm doing here, I go through all the elements of the calendar and I remove them. Okay. Okay. Now we are going to implement the class urgent care. Let's insert the class module. We are going to call it urgent care. Now let's think about the properties that this class should have. So if we, all right. So what we have done so far is we have implemented the patients, the class for patients. We have our waiting room, we have our exam room, and this is going to be our urgent care. All right. The urgent care, the class that we're going to implement is essentially the brain of our simulation. So this is the class that tells everyone what to do and how these objects are going to interact. So this is the class that tells us that, okay, when a patient arrives, check the waiting room if it is, or check the exam rooms. If either of them is empty, send the patient to the exam room. Otherwise, send the patient to the waiting room. So these are the functions of urgent care, the class urgent care. Now, what are the variables that I need to define for urgent care? What do I need to know, or what kind of properties my urgent care should have? The class. So I have the patients, I have the waiting room, exam rooms. So maybe we should start with yeah, so that can be one of the properties. So let's add that. So we have patient arrival times. This is something that the urgent care need to know to operate, okay, to simulate the flow of the patients. We also need to know private exam duration. Right. Now, as exactly, here, waiting room is inside the urgent care. So I'm going to also have a waiting room here. Waiting room as, remember we had an object for it, a class for waiting room. So we are assuming, in this exercise that we only have one waiting room, but we might have multiple exam rooms. All right. I'm going to declare a collection to contain these exam rooms. So I'm going to call it exam rooms as collection. I also need to know how long the urgent care is open. So I have hours open is double. Okay. Questions?
Yeah, so why is it double? What is the difference between double and long?
Oh, so double we use for real values, real numbers. Long is for integer numbers. So ID takes only 1, 2, 3, 4. So ID doesn't take 1.2 or 1.3. Yeah, so this is long. And for real value like 1.2, as decimal, we use double. Okay. I also did urgent care. My class also keeps track of the calendar. It also handles the calendar. So I'm going to have the calendar here as well. Okay. So these are the inputs of the model. I have the calendar so that the urgent care, again, this is the brain. It knows that what is going to happen when. That's why it has access to the calendar. We have our waiting room and exam rooms. So this is a collection. So we are going to create the exam rooms and put them in this collection. Okay, so now instantiation. We are going to create our exam room. Now these are the things I need to pass. I need to know hours open. So this is double. When I create the urgent care, I need to know number of exam rooms. I use long. I need to know patients per arrival time, double. Okay, so these are the specifications I need to set up my urgent care. The time that is open, number of exam rooms, patient arrival time, and the exam duration. So now let's set the private variable. So this is urgent care hours. Do this is a local variable. Just copy and paste it down. Is and exam duration. Okay. So to create an urgent care, I need to know hours open, number of exam room, patient inter-arrival time, exam rooms. So this is something that I'm going to pass to this class or object, and I'm going to store these values in my local variable. Okay, that's the variables that end with underscore. I'm going to create a calendar. So remember that we need to use set because calendar is an object. I forgot to add the underscore after calendar. So my calendar is equal to a new simulation calendar. Okay. Now I want to create my exam rooms and put them in the collection. Again, remember we defined the collection of exam rooms here, but we haven't yet initialized it. We just told VBA that there's going to be this collection. In order to initialize it, we need to use the term, the keyword new. So let's initialize it, exam room collection. So set exam rooms new collection. This is now, I'm able now, this is, that enables me to add exam rooms to this collection. Now I'm going to create each of the exam rooms and add them to this collection. This is the exam ID. I'm going to have a loop for loop statement. It starts from 1 to number of exam rooms. Okay, so I'm just looping through the exam room. Okay, from let me scroll up a little bit. The first exam room ID is 1, and it goes up to number of exams. If I have 2, the first one gets ID 1, the second one gets ID 2. Now to create an exam room, I use a dim exam room as a new exam room, right? I need to initialize it, so that's why I use create, and it only take exam room ID. Okay, so are you with me? So I'm going to create as many exam rooms as I need. That's why I have this for loop. This is how we define the exam room. I'm telling VBA that go find the recipe for creating exam room. This is how we instantiate the exam room. I need to pass the ID to exam room, and then I add the exam room to my collection. The name of the collection was exam rooms underscore dot add this exam room. Okay, so let's see what's happening here. I'm going through this loop. Each iteration of this loop, I'm creating an example, and then I add it to the collection, right? Now, if I run it, I will see something funny here. Because if I create an exam room, imagine that we have, this is our exam room 1. I create this one. I put this in this collection. This is the example. Right. So the way that VBA works is that when you create an object, it allocates part of the memory to this object. Right? Now, next time that I use exam room and I want to create a second exam room which has ID 2, right? VBA still thinks that I'm referring to the same memory location. So when I use 2, it goes and updates the ID of the previous exam room to 2 as well. So in other words, let's do this. So I create an exam room here. Okay, when I create an exam room, VBA gives it a location in the memory. Imagine that this is here. When I put the exam room in the collection, this is how VBA works. It assigns this location to the location in memory to this location in the collection. Now, if you create the second one, again, it does the same. Third one, it does the same. So now you end up with exam rooms that all have the same ID. So if you have, for example, 10 exam rooms, they all have 10. So now in order to solve this problem, what we need to do is to destruct the exam room after we add it. So we set exam room to nothing. Okay? So might get a little bit confusing, but the idea is simple. So just remember that we create an object, we call it exam room. All right? This stays in the memory unless I kill it. Right? So since it stays in the memory, although I'm updating the ID of this exam room in the next iteration, it is in my memory, it's still in my memory, so they are all referring to the same location in the memory, so they all behave the same way. So in order to avoid this problem is to kill this object, and then next time for the next iteration, we see that, well, there is no exam room, so I'm going to create it again. Otherwise, since it has stayed in the memory, VBA knows that, okay, I already have an exam room, so I'm just going to update the ID. But just remember that kill the object, destruct the object after you add it to the collection. Right? This is just remember to do this. All right. So we have 2 more minutes. Let's maybe continue next time. But for the so for the next class, we are going to implement this algorithm. Make sure to review it. Okay. This is a general discrete event simulation algorithm. We set up the simulation, and we schedule the first event. In our urgent care, the first event is the arrival of first patient. We advance time to the arrival of first event. We process the event. We again schedule next events if necessary, and then we again advance time. We keep doing it until some termination condition is set. Right? Is there any questions before we call it a day? So make sure to submit your files, just even if you haven't implemented the steps to get the credit for today. And I'm going to post this video online in case you want to watch it.